Okay, section 4.3. So we will not only be talking about e to the x. Sometimes we'll think about like 2 to the x or 3 to the x or any number you can think of to the x power except 0. And in those cases, when that happens, the derivative is going to be the number to the x power times the natural log of a. And just like a tip, natural log of a, that's just like a constant. That's just a number. That's not a variable. Like 4 or 5 or something like that. And then below I have the exponential function with the chain rule. So we kind of already did this, but just a reminder. Let's do a couple of examples. Find the derivatives of the following equations. Don't forget the chain rule. Okay, so I have e to the 2x. So I'm just going to put 2x in parentheses to remind me that this is a chain rule problem, that it's not just e to the x, it's e to the 2x. So to do the derivative, it's going to be the derivative of the outside, which I know is just e to the x. Then I plug everything back in. Then take the derivative of the inside, which is 2x. And so e to the 2x times 2. Okay, part B, e to the negative 4x plus 1. Very similar, b prime of x. So the outside function is e to the x, so I'll take that derivative, which is still e to the x, and then plug the inside function back in, and then multiply by the derivative of the inside function, which, let's see, e to the negative 4x plus 1 times the derivative of negative 4x plus 1 is just negative 4, and I'm done. Part C, this one is a little more complicated. The exponent is like a 5th degree polynomial. So still though, there's an outside function, that's e to the x, and an inside function, 2x to the 5th minus 6x squared, 16x squared. So the derivative of the outside function is still just e to the x with everything plugged back in, and then times the derivative of the inside function, 2x to the 5th minus 16x squared. So simplifying, e to the 2x to the 5th minus 16x squared. And then times the derivative of this one is 10x to the 4th minus 32x. I have a little bit of a cold, so I apologize for how terrible I sound. I'm just proud that I made it this far into the videos. Okay, number 2. What is the derivative of the function v of t equals 3 times e to the negative 2t cubed minus t plus 1? Phew! Okay, I can ignore this 3 in the front because it's a constant and just leave it as is. So 3. And then e to a power, the e stays the same. I just need to multiply by the derivative of the inside function. So negative 2t cubed minus t plus 1. Take the derivative. So simplifying, I still have 3e to the negative 2t cubed minus t plus 1 times negative 6t squared minus 1. Boom, done. All right, number 3. What is the equation of the line tangent to f of x equals x plus 1 over x at x equals 1? So I think the first thing I would do, every time I see 1 over x, my thought is always rewrite it to be a power of x. The reason I do that is because it's easier to take a derivative. And then I need a couple of things. I need f of 1. It's just regular f of 1, not the derivative, although I'll need that too. F of 1 equals e to the 1 plus 1 to the negative 1, which is just going to be e squared. 1 to any power is just 1. 1 plus 1 is 2, so I get e squared. So that tells me 1e squared is on the line. Okay, the next thing I need is the slope, which should be f prime evaluated at 1. So I've got an exponential function here, and I've got an outside function and an inside function. The derivative of the outside is just still e to the x. And then the derivative of the inside I'll work on next. So e to the x plus x to the negative 1 power times 1 plus, oh actually 1 minus x to the negative 2. So then I'll plug in 1, f prime of 1. So e to the, let's see, 1 plus 1 still, so 2. And then times 1 minus, 1 minus 1 to the negative 2 power. I think that's 0. So I get e squared times 0, or just 0. So this actually makes my tangent line very easy. This is the slope. So y minus e squared equals m, which is 0, x minus 1, or y minus e squared equals 0. So I'm betting I did something wrong, but for funsies, let's pause here and we'll go look at Desmos and see if I did it wrong.